Okay, so you guys, today I'm going to go over projectile motion. So my goal for today is I'm gonna explain to y'all what you need to know and what you guys will probably see on your exam. So hopefully, let's help you guys. So let me draw this like so what is a projectile, right? So projectile, like we kind of went over last time already. Um, well, we didn't go over it, but the reason why you guys were doing vectors is we're gonna have to break these like velocities into the x and y components, right? So the goal of this unit is to realize that these some of them will stay the same, some of them are changed depending on which direction the ball is moving, right? And then that's why actually I think your teachers kind of went over like all the vectors. So here, let's start with this. So the main formulas we're going to need are pretty much just the top three, right? So VF equals V0 that's AT, delta X is equals to V0 T, that's 1/2 T squared. Then this one too. This one is not used as much as the other two. Mostly you'll probably use these two just because you'll have to solve for time. If you ever lost with these, you probably need time. So yeah, for a two. Let's start with one example. So I want y'all to imagine I'll give you any number, Joe. I just want you to realize something. If I give you a delta y of something, and I drop a ball, right? I'm gonna give you the distances later. So if I drop a ball and I'm given the delta y, I can use this equation, right? I can do delta y is equals to v0 y2 plus 1/2 a y2 squared. Okay. And the reason why I can use this is I know that if I drop it from the beginning, I know that I can cross this off, right? Because my initial is 0. I go to 0. And my acceleration for any dropping object is just gravity. So I can do substitute G for that A. So now, if I need to solve for time or whatever, I can use this. So time is just 2 times the delta y over G, square root of all that. So for any height, let's say I give you, I don't know, let's see, 100 meters, I can solve for T. So for a 100-meter drop, I'm gonna get that in my handy dandy calculator. So 2 times 100 divided by 9.8, and then square root all that. So that's like 4.5 seconds. Right? But that's not too bad, right? I want y'all to remember this formula because you'll probably use it again. So that's it. Another, so I guess I can do here, another question. What if now I, instead of just dropping the ball, I'm gonna use the same height, 100 meters. Instead of just dropping the ball, I roll it off, right? Now I'm gonna have a starting velocity. I don't know. V equals 10 meters per second, right? So if I roll it like that, Now, instinct tells me, or not instinct, but my intuition tells me that it's going to roll off here, and then we're going to do something like this, right? It should. Since I have the velocity now, it's going like this, right? Okay, so let me kind of draw that. So now I have introduced some kind of like distance here, right? And I call that delta x because it moved from here to here. Okay. Now, um, what do I know here? I know that the ball is going like this, so I know that it's dropping from the same height. So that the reason why I kind of did this problem is it should drop with the same rate, right? Because acceleration is only going this way, it is equal to g. So that delta y, or sorry, the time it takes to drop should be the same. The time is still that 2 delta y over g. So if I plug in all the numbers again, 8.8, I actually get the same thing, which is 4.5, right? Cool. So now the only thing that changes though is I have that change in x now. So this is can be solved using this problem. Delta y, sorry, delta x is equal to b0 x t plus 1/2 x t squared. And I know that my starting velocity in the x only is 10. So 10 times time. And then since I don't have any other forces, this is going to be 0 because there's no acceleration in the x. So if I know the time taken, which is 4.5, I can get a range, which is what is this, 45 meters. So this one is always true as well. So these two, for a horizontal problem like this, I think they call these horizontal projectile motion, right? Since it's only has a horizontal x velocity in the beginning. Cool, cool. Let's move on to the next one. Now, what if I introduce an angle? Oh no. So now, like, imagine if I'm kicking a ball, right, or whatever. Imagine I'm like here, I'm happy, kicking the ball, right, kicking the soccer ball, whatever. And if I kick a ball at an angle, it should launch kind of like this, right? It's gonna go in a projectile like this. It's gonna reach some kind of like maximum height somewhere. Okay. So let me give you a easy number. Let's say I launch that ball wait, hold on, sorry, at a 30-degree angle. I'm gonna use easy degrees at, I don't know, the I'm gonna use a number, maybe 20 meters per second, which is pretty fast, by the way. So then I'm gonna ask you, hey, how high did it go? And then also how far did it go? What's my x, like x max? Not for Christmas, but displacement maximum, right? Okay, so same thing here, like what we kind of did last week. When we have vectors, we're gonna put them into their components. So this one, right? So we'll triangle. Okay, let me draw it. Now vector is that 20, which on my graph. is 30 degrees from the axis. So like what you get your two teachers were doing, you can do x and y, right? Pick a little table. V0x and V0y. So the V0x is this one. It is my cosine. This is 20 cosine 30. And then the other one is the y of this vector, right? Which is 20 sine 30. And I kind of picked the easy triangle. So this one is a 30, 60, 90, right? Don't forget these. Right here, 30, 60, 90. And this is L, here's 2L, and L over 3. So I know that this one, the y, is going to be just half of that 20 with the 10. And the x will be 10 root 3. Right? You can do this. Or you can put them into decimals or whatever you'd like to do. Okay. And then I will solve this the same way. So I'm gonna split my problem into two, right? Most likely you're gonna have two unknowns in this problem. So you're gonna need two equations to solve them, right? One of them will come from the horizontal or the x direction. So the equation I'm gonna use for that is that the x is equal to v0 times time plus 1/2 a b squared. And again, there's no acceleration in the x, so that goes away. So this is always my range formula. I know my V0x, my starting one, which is just right here. So starting with 3 times time. Okay. So yeah, like I said, you'll have two unknowns, so I need another equation, right? So I'm gonna get that from my vertical side. So let me write it right here. Actually. My vertical equations, there's gonna be two of them. Um, what I'm gonna use for this one is the fact that this is symmetrical, right? I know for a fact that when I reach my maximum height, that my final velocity in the y will be 0, right? Because I'm changing directions. And that's my maximum. So when I throw a ball, when it reaches the maximum, it's going to be the slowest, or sorry, it's going to be 0 in the y. So I'm going to use my handy dandy equation, the first one, to solve for time. So then I know that at that place, for the 0, v0y in the beginning is 10. I know that my gravity is 9.8. The g is going to be -10, which equals to 9.8 times time. And then I solve for time. It's going to be like around 1 second. Let's see. 10 divided by 10.8. It's 1.02, like 10. So it took 1 second-ish to get to that maximum height, right? Okay. So, since like I told you, it's symmetrical, that's only half of the flight path, right? I need the other half. To do that, I simply just double it. Oh, wait. No, I don't want to erase it. I just double this, right? To get the maximum range. If you put this only, you're only going to get the range from here to here, just half. That's flight time. Make sure you double it if you're doing these problems. So delta x equals to 10 root 3 times 1.02. So put this 10 root 3. So this is like 17.32 or 10.02. And what did I get? Wow, that's just a few super close to six meters. Right. Okay. So yeah, these aren't too bad. Make sure you guys get your this is always the first step. Make sure you break it into its components. Solve for the two, horizontal and vertical. You'll need time again, like the previous question that we did, most likely. Unless your teacher wants to do it backwards, then you'll have to go that way. And then you should be able to get the answer. Cool, cool. Okay, so let's do this example together. This is a FRQ from a previous repeat exam, which they kind of saved on for the MIT textbook. But let's go over it. It's all different and pretty cool, I think. Okay, so notice how, so it's again, it's another kicking the ball or whatever. It says the ball mass, blah, 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 0.5 kilograms, initial at rest. Let's kick directly towards the fence from a point 32 meters away, as shown above. The velocity of the ball as it leaves the kicker's foot is 20 meters per second at an angle of 37 degrees. Okay, cool. The top of the fence is 2.5 meters high. The ball hits nothing while in their flight, and the air resistance is negligible. Okay, so it says A, determine the time it takes for the ball to reach the plane of the fence. Okay, and then B, it says, will it hit the fence? If so, how far below the top? Blah, 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 blah. All the, okay, so let's see. This is the problem. Yeah, let me take a screenshot so I can put it on the next page. Okay, see if I can do this. Okay, cool, there you go. So the first thing I would do is, again, secret to this, it's most likely finding the time. So, but at least the first step I'm going to do is I'm going to get my components for that vector, right? So that's starting velocity. So it's 20, and I made v0y, v0x. Again, I'm going to make my little table. That's like the table. I'm going to make it too. V0x is just the, let me put the angle 37, just whatever this is times the cosine. They kind of already give you the cosine, so it makes your life easy. So it's just 20 times 0.8, right? So what is that? 20 times 0.8. What's my calculator? 16. Cool. And then the y is the sine, right? So this one is 20 times 0.6, which is the 12. Yeah, 12. So that's not bad, right? Okay. So this one, the only difference is, remember last time we did this, we kind of found the time to get here, right? We're gonna do the same thing. So we don't know where this ball is going. So I'm just gonna assume something. I'm gonna assume it went over, whatever. Or you can assume it went under, but it doesn't matter. But what I can do is at this location, I can find the time, right? Because um again, I can split it up into two sides, horizontal and vertical. I can solve for something. I don't know what I'm gonna solve for, but guess what? Let's figure it out. So delta x is v0x times time, and then this one is the same way, v0y t plus 1/2 y squared. So at that location here, I know my delta x is 32. I have my v0x, which is that 16, and I can find the time. Cool. The time is just 32 divided by 16, which is in those 2 seconds. And now, if I use that time of 2 seconds and I plug it into the vertical, right? I should be able to find that height, whatever that is. So delta y equals to v0y, which is 12. The time is 2 seconds plus 1/2 negative 9.8 meters per second squared times 2 squared. That's 24. No, that's 4.9 times 4. I always forgot about calculator. 4.9 times 4, 19.6, and 24, which is 4.5. So it did. So at that height, I'm sorry, at that time, right, at 32, 2 seconds, I know that the ball was at 4.5, sorry, not 4.5, 4.4. So it did go over it. I think what was the question asking for? Oh, so A, we kind of answered A already. This is A. This one right here. And then B, and if I just C, it's just going to be 4.4 minus that. What is the height? 2.5? 4.4. And it's 1.9 meters. Right? It was 1.9 meters above the frame. That was the second question. No, the graphing. Ooh, the graphing. I know that at 2 seconds, what was the speed of B? Yeah, 16. Okay. So v0x stayed the same for 2 seconds, right? And the vertical component, it went from, what was it, 12, so from 12, and something like this, right? Oh, was it 4.4? What was it? Yeah, okay. So your y will always be kind of negative, decreasing. So if it's like doing something else, that means you just got to start over. Okay, let's do another one here. All right. This is like the final boss of problems. Well, not final boss, whatever. But if now I combine everything I just learned into this. So let's say I have a cliff or whatever. I want to make it the same height. 100 meters. And I picked it at 20. You know what? Let's do 50. At an angle of, let's do a weird angle. I don't know. Maybe not. We'll do 30. It could be weird. So now the question is, put it like this, right? The question to you is, what is the maximum height? Then delta x and how fast is it when it ends, right? And what is its final velocity when it like finally reaches it, before it hits the ground, sorry. So this would be like a question that they would kind of ask. Because it kind of gives you all the stuff that you need and really that you need. Okay, let's do it. So first things first, what you're gonna do is we're gonna break that velocity into the components. So I need v0x and v0y, right? It's a 3060, makes my life easy, but we can do whatever. This is gonna be 25 and 25 basically. 25, 25 basically. Okay. So I'm going to start with, it doesn't really matter, but I'm gonna start with the max height. Max height will just be whatever this much was plus this, right? So if I find this, I can find it. And the way to find that, like from the previous problem, is using this one, right? V0, sorry, V final plus V0 plus AP. Find out the zero is for the final, so the Y, 25 minus 9.8 times time. The time is just 35 divided by 9.8. That's what is bad. It's 2.5 seconds, 2.55. So if I now use this equation, I can find it. Yeah, delta Y. Or what do they call it? Max height? H? Yeah, I'm gonna call it H. H, just whatever that is. V0Y is 25. The time is 2.5 seconds, 2.5. Minus 1/2, 2.8 times 2.55. Let's see, what's that? 25, 53.75, minus 12.9, that's 5 squared. It's 31.225. Okay, let me just do all this real quick. So the height is 32.5 meters. So if I want to find the max height, right, I just add whatever this is. Let's do it. For H max, if it's 32.5, that's 100. Okay, if that makes sense. Okay, and then the next thing I can find is delta X, right? Again, I'm gonna do delta X equals to B0X times time. Delta X, what was B0X? Oh, 25 by 3. So I still need to find time, right? Okay. I'm gonna use this equation again. Look for G. Is that okay? Okay. Because what I can do is I can now use this one, right? The 100 for my delta Y. I'm gonna use negative 100 because the displacement is negative, it's going down, right? I use this as my origin. U0y was 25.9 plus 1/2 of 9.8 times t squared, and negative 100 equals to 25t minus 4.9 t squared. So now I have a quadratic. I'm going to set it equal to 0 because I know how to solve quadratic. We've done this many times. How many is there most? I'm going to do squared plus. You can also use, what do you call that? Any way to solve quadratics. I'll give you a second. That's 25, 100. And then what am I getting? Decimals told me it was 10. Sorry. I'm going to give you a graph, right? If you graph it on whatever, like this, and you're just going to give me the positive one. It's going to be 7.33. 7.73, sorry. 7.4. So the flight time for this, uh, 7.7 seconds, which now I can find my delta x. The delta x is 25 root 3 and 7.74, which is it's 25, which will give me 335.15 meters. That's my range. Nice. That's pretty far. Okay, now the final thing is this one. I need to find the final velocity. Okay. So how do I do that? I can find final velocity because what I can do is, since there's no acceleration in the x, this will stay the same, right? Nothing has changed in the x. So the only thing I need to find is that y. So this will stay the same. And what I can do is then use this equation, find the y velocity. The fy is this 25 minus 9.8 times 7.74. And this one will be negative, actually. Because at the end, it's going in the downward direction, right? So dfy is 50.85 negative. So then to get my final velocity, I just do the Pythagorean theorem. I can do 25 with 3 squared plus negative squared. I'm gonna write all these down. That's fine. And then times 2 8 92 and df is square root of 4 y equals 0.92. So with that, and final velocity is 56.79 meters per second. So that's it. So this one kind of takes longer than the other ones, but hopefully it's not bad if you follow all the, like all the steps, right? It's kind of just combine everything. The only thing that's kind of weird is this. Well, you guys have done quadratics since other the two many times, so it shouldn't be too bad. Okay, cool.